Welcome back to Academic Plug. So in this video, we're going to go through the 2018 Natural Sciences Term 3, Grade 8 question paper in revision and in preparation for the 2025 Term 3 exam that you guys are going to write, all right? So on the screen, we have our question paper on the left. And for those who are skeptical about the scope, you may ask yourself whether this 2018 question paper is it gonna help you answer the 2025 term 3 exam? Well, the answer is yes, because the scope that was used to set this 2018 question paper is the same scope that is going to be used to set the term 3 2025 exam that you guys are going to write, right? So the scope is 100% similar, and being able to answer questions on this question paper will allow you to answer the questions on the term 3 2025 exam that you guys are going to write. So the scope includes forces, electric cells as energy systems, resistance, series and parallel circuits, safety with electricity, energy and the national electricity grid, and the cost of electrical power, right? So, and yeah, you can download this question paper through the link in the description, and it will land you on this page. Then you will be able to come here and download this question paper. And if you want to check out the scope, you can also use the same link, which you can see here. There will be the scope and predictions button. You click there, you'll be able to see the scope for term 3 and also term 4 and so on, right? So yeah, before we delve into the questions, we have some useful educational tools. So talking of term 3 scope, we have put together 200 natural sciences exam questions, and the questions basically include everything that has been covered for this term 3, and I mean everything that is on the scope. There will be questions about pretty much everything that has been covered in class and what you are going to write in the term 3 exam, right? If you also struggle in terms of understanding natural science topics, and it not only for natural scientists, you could be struggling with maths, we have a very affordable tutoring program. For $50 a month, you can have a tutor who is an online tutor, so you'll be basically be taught from the comfort of your home. So for $50 you can be taught natural sciences, mathematics, and any other subjects that you guys find challenging, right? Just for $50 per month. And I know some of you do carry pocket money, which equals $50. So some of you can actually afford this by yourselves, right? So without wasting much time, let's delve into the questions. And before we do that, I want you guys to also know that we are going to use the help of CAPS AI. So CAPS AI is pretty much a academic AI that's gonna be helping us make sense of what the questions are, how to go about answering them, and the explanations for the answers for these questions, right? So you can also use it for your homeworks, your assignments. If you feel like sometimes you just don't know how to write your assignment, your homeworks, I mean, CAPS AI is there for you, right? It's very reliable. It's gonna give you straight A answers, right? So make use of it. And you can also ask it, it's pretty much also a tutor. You can pretty much ask it any questions that you're struggling with for natural sciences, even for mathematics, right? So it's it's gonna be very hard for you guys not to pass these subjects, right? So let's get into the questions. Question one: one component in a series, right? Okay, so let's see what Caps AI says about this one. The correct answer is A, right? Which says same current strength in all components. In a series circuit, the same current flows through all components, one after another. There are no branches, so current doesn't split, right? Okay. The second question says shadows are formed because all objects reflect light. B, of opaque objects. C, light travels at high speed. D, objects allow light to pass through. Which one is correct? Okay, correct answer is B, which is of opaque objects, right? Okay, opaque objects block light from passing through. This causes a shadow to form behind the object where the light is blocked. Okay, that is the answer. 1.1.3. An example of a non-luminous object is A, sun, B, moon, C, firefly, D, star. The correct answer is B, moon. So the moon does not produce its own light. I mean, we are familiar with this, right? Unless, I mean, basically understanding the moon is, I mean, actually, let's actually talk about this. Who does not know the moon, right? Who has never seen the moon, right? I mean, randomly, you just look at the sky, you see something, um, ref- I mean, to you, it's lighting. I mean, if you are to say what's happening with the moon, which you're seeing on the sky, you will say it's lighting, or rather, it's right. It, it's got some sort of light, but then it's basically reflecting the light from the sun. So it is not like the sun. The sun actually is like a burning a burning ball, right? It's like flames all around it, right? That's why now it produces its own light, right? As compared to the moon, which does not produce its own light, but then it only reflects the light from the sun, right? And also animals, right? they every time they see the moon, it's either they will is it the owls that make noise when they see the moon? I don't know, but I think um foxes or is it wolves when they make that sound at the hill of the mountain, right? So animals are also aware of the moon, right? But then in this case, the moon does not produce its own light. It reflects light from the sun. That makes it non-luminous. So luminous equals gives off light. I mean, the sun is luminous, right? Non-luminous only reflects light. Okay. 1.1.3, 1.1.4. The filament in a light bulb is made up of A, copper, B, nichrome, C, tungsten, D, magnesium. The filament in a light bulb is made up of C, tungsten. So a tungsten is used in light bulb filaments because it can withstand very high temperatures without melting and glows brightly when heated. So 1.5, the component in a circuit that opposes the flow of charge in a circuit is A resistor, B emitter, C cell, D switch. A resistor. So a resistor limits or opposes the flow of electric current, protecting components or controlling current levels in a circuit. And later on this question paper, we will also go through the symbols, right, of these resistors, the emitter, the cell, and the switch, right? And you'll be able to download a picture that has all these symbols that you are most likely to be asked about, right? And even for the technology subject, right? So yeah, it's gonna help you not only in natural sciences but also in technology. So the component in a circuit opposes. So we've done this one. Which yeah. So 1.2.1, a component which overheats, melts, and breaks an electric circuit. Answer is fuse. A fuse is a safety device that melts when too much current flows, breaking the circuit to prevent damage or fire. 1.2.2, a component in an electric circuit that converts electrical energy into various forms of useful energy is an output device. Output devices like bulbs, buzzers, or motors change electrical energy into light, sound, heat, or movement. A device which changes electric energy into kinetic energy. Electric motor, right? An electric motor spins or moves when powered, converting electricity into movement, kinetic energy. 1.2.4 consists of putting a layer of one metal on top of another with the use of electricity. Electroplanting. I mean, made a mistake. Electroplating. So, electroplating uses electrical currents to coat a metal object with a thin layer of another metal for protection or appearance. So, I think we have like a couple of questions that touch on things like electroplating, the electric motors within those 200 plus questions. So, I mean, after completing those 200 questions, I mean, it'd be very hard to fail these questions, right? Because everything is explained there in depth. By the time you come across a question paper, it's like you just, walking in the park. It will be very seamless. It'll be very easy after you've completed over 200 questions. So make sure to go practice those questions after you watch this video. All right. So 1.2.5, metal containing iron that becomes magnetic when an electric current passes around it. Electromagnet. An electromagnet is made by winding wire around iron, and it becomes magnetic only when electric current flows. Okay, so that's the last question for 1.2. Then 1.3. Match a statement from column A with the current term from column B. Write the question number and only the letter of your answer. Column A. Okay. So we're gonna go through this 1.3.1. The the build up of electric charge. Okay, so let me quickly read through column A just to make sense of it, right? Um, and by the way, these questions, I mean, they're not so compared to EMS questions. The EMS questions, you can at least make sense of the keywords, but when it comes to natural sciences and technology, it's very hard to just use keywords of these questions because they are definition. They have like specific definitions, right? Which require you as a student to have read it somewhere, right? It's either from the notes. So that's why it's important to have the notes. So the link is in the description where we break, because we not only define these things on the note, we also give you like pictures, right? Because some of you find it very hard to just read text, and it becomes hard to even cram just text. So it becomes very easy if you're looking at the pictures. So our note has a lot of pictures, right? So it makes it easier for you guys to cram, and we also make examples, right? So make sure to get the note right. Okay. So the buildup of electric charge, that's 1.3.1. 1.3.2 says process which causes electrons to be transferred from the surface of one object to another. 1.3.3 says pulling something towards itself. 1.3.4, like charges are known to have this effect. 1.3.5, caused when sparks hit the air around it rapidly, causing a sound wave. Okay, so I like to do this before I answer these questions, just to make sense of the questions, and there are the questions in column A and the answers in column B, right? So that when I start now matching them, I know which direction to look, right? So column B is friction, attraction, static electricity, repulsion, lightning, thunder, right? Okay. So let's see what CAPS AI says about these ones. So the building up of electric charge is static electricity. Static electricity is the accumulation of electric charge on a surface. 1.3.2, process which causes electrons to be transferred from the surface of one object to another. Friction. Friction between two objects can transfer electrons, creating static charge. 1.3.3, pulling something towards itself. That's attraction, right? Attraction occurs when opposite charges or magnetic poles pull towards each other. Okay, 1.3.4, like charges are known to have this effect, which is repulsion. For example, plus and plus repel or push away from each other. Okay, 1.2.5. Caused when sparks hit the air around it rapidly, causing a sound wave. Answer is F, which is thunder. Thunder is the sound created when air expands rapidly due to the heat from a lightning spark. So we also explain thunder more uh elaborately on the notes, right? So we even give the pictures to demonstrate like how the whole thunder uh phenomenon happens, right? So make sure to get the notes. And we have questions from the NS term 3, the 200 questions and answers. Okay, which says, why do objects like the moon and mirror shine even though they are non-luminous? So if you know the answer, I mean, like right now, before even actually looking at the notes, because the answer for this question is there on the notes, but I'd like to know what you guys think of this, right? Like, what do you think, right? If you do, write that answer in the comments, right? But also make sure to check the answer on the uh whilst you practice the 200 questions and answers, right? All right, so let's come to question 2. So 2.1 refers to the circuits below. We have A on the left and B on the right. So yeah, 2.1.1, which of the above circuits A or B represents a parallel circuit? I mean, we all know which one, right? Unless you don't. But so it's B, right? And the second question went on to say, give 2 reasons for your answer above. The bulbs are connected on separate branches, as we saw on the picture. So these branches are those ones at the bottom of the circuit. As you can see, there's like 3 bulbs there, right? Okay, the second one says current has more than one path to flow through, so each bulb gets full voltage, right? Okay. 2.1.2. What would happen if what would happen in circuit A, which is on the left, if a light bulb burnt out? B, give a reason for your answer above. I mean, also that answer is obvious, right? I hope you got it right by yourself. But then the answer is all the bulbs would go off, which basically means they will switch off, right? So the reason will be because it's a series circuit. Breaking one bulb breaks the entire circuit. And also we have a lot of questions on this, the light bulbs and all the components. So I mean, make sure to practice those questions before you go and write, right? And yeah, because some of you might think it's a lot of questions, but trust me, once you start going through like 50, I mean, you can go through 100 questions in less than 6 hours if you really are attentive like that, right? If you're not on TikTok here and there, I mean, that's what will distract you. But if you focus and you say, I want to finish all the questions in a day, you can basically do it without even, and the following day you will be known a bit way more. Like, and if you do that for like 3 days in a row, I mean, how are you not gonna get a distinction by the time you go write the exam, right? Okay, so we are on 2.1.3. In which circuit A or B will the bulbs be brighter? A or B? B. Okay. In a parallel circuit, each bulb gets the full voltage, so they shine brighter than in a series circuit, where voltage is divided. Okay. 2.1.3 that was, then 2.1.4. Draw a circuit diagram with the following components. 2 cells in a series, 3 bulbs in parallel, 1 resistor in series, and an open switch. 2.1.4. So that is our circuit diagram. So you can see the 2 cells at the top there. Okay. 2 cells in series, which basically means that they are on the same wire, right? Just beside each other. And 3 bulbs in parallel, as you can see at the bottom there, there's each bulb on its own wire, and 1 resistor in series. So there are 2 types of resistors. I mean, in the way that you can draw them. Let me show you. Um, yeah, that's it on the top right, if you can see properly. So there's a resistor which is like in a box shape, and then wires on the left and on the right, right? Or you can sort of do it in a zigzag way, right? So yeah, there's two ways in which you can draw a resistor. So that's our resistor up there, and one open switch, right? Which basically means is off because it's not connected to the other point in which allows electricity to flow. Okay, let me see. Yeah, so tips when drawing, start with 2 cells, but this is basically for when you are drawing, right? And you should make sure that you are familiar with these circuit symbols, these ones that I just showed you. So you can simply go to the page. The link is in the description. Then it's gonna land you here, right? All you have to do is scroll down until you come across it down here. Then you can download these circuit symbols and make sure that you're familiar with them. I mean, this is a picture that you can simply save on your phone and sort of take a look at before you go and write your exam. And yeah, but mostly to understand how it is visually, and also practice how to draw one, right? So you should take time and learn how to draw these ones, because you don't necessarily have to be like Picasso, like like you're drawing a picture or something like the Mona Lisa. No, you just have to learn how to draw these small symbols, all right? Okay, so let's go to 2.1. Briefly explain what you could do to make each practice safe. So we are given 2.2. So we're given a two scenarios. So there's A on the left and B. So on A, at least we can see there's a bunch of plugs just sort of piled up in one place. And B, we have a finger with, is it drops? They look like drops, right? So a person is pressing down a is it a bread toaster? Yeah, it's a bread toaster, and a person is sort of dripping with water, right? And they're pressing down that. So okay, 2.2.1 now. Briefly explain what you could do to make each practice safe. Um, so image A, many plugs in one socket, overloaded plug point on B, it's finger pressing down a bread toaster, with water on the hands, right? As we saw. Okay, safe practice. Use a power trip with overload protection or unplug unused devices, right? Second one says avoid plugging too many appliances into one socket to prevent overheating or fire. Use separate wall sockets for high power devices like heaters or microwaves. Okay, image B says use a handle or knob, not your finger to press the toaster lever. Make sure your hands are dry. I mean, we saw that person was kind of dripping with water, right? So you should make sure the hands are dry. So basically, you can just sort of think practically of what the practical solutions could be, right? I mean, at least the picture gives us clues of what's going on, and we can basically think of solutions from that uh, perspective to say what could be the safe measures of doing what they're doing, right? So, and it says, and keeping fingers away from the heating elements to avoid burns or electric shock. All right, so study the diagram below. So 2.3.1, we're given a bulb here, and we're supposed to label it, right? We'll provide labels for parts labeled A to E, and 232 says name the energy conversion taking place when the bulb is working. Okay. So we have this picture that you guys can sort of download also. And, you know, because all the labelings that I required there, they are here, right? But all we know is that the surface of this bulb, at least on the part where it lights, is the glass bulb, the gas filling inside, right? The tungsten filament, which we were also talking about in the first questions, supporting wires, lead wires. Yeah. So make sure to also download this picture. So the electric bulb uses electrical energy to produce light, which is visible energy, and also gives off heat as a byproduct. Okay, so there's also questions from the NS Chum 3 200 plus questions and answers, which says a circuit E includes a buzzer, a switch, a battery, and two resistors. The buzzer is not working. Suggest three possible faults in the circuit that could cause this and explain how to test for each. Okay, so for those of you who immediately know the answer, at least write it in the comments, but then you can also see the answer on the 200 plus questions and answers. All right, so question 3.1. Study the diagram below and answer the questions that follow. So we've been given a mirror, and the questions say supply labels for each of the following. OZ, which are these lines, as you can see, OY, which is the one in the middle, OX, which is the one going to X, and there's a couple of angles in there that I guess we're gonna have to label. We're gonna have to give labels. All right. So let's get to it. There also the other questions. Okay, we're gonna give labels for angle B and angle D, and also determine the values of D, B, and C, right? As we can see them there. But we are given a 40 degrees there, as you can also see. So, okay. So, okay, the OZ is the incident ray, right? Let's take a look at it. Which is OZ, right? It also has a 40 degree angle, which is the incident ray. OY is normal, which is the straight line, as you can see, which is called normal. OX, reflected ray. OX is the reflected ray. Okay. Angle B is angle of incidence. And we actually have full definitions of this. And we also have like a couple of more angles, like, as you can see this question, we have other questions under 200 plus questions and answers, right? So make sure to practice that so that you're not confused by these questions. So that was our angle. Angle of incidence, which is B, right? That's what our angle B, angle of incidence. Angle of reflection, which is angle D. Okay, this is our angle D, which is angle of reflection. All right, so determine the value of the following angles. So we were given angle B, right? Okay, so we're already at 40%. 40 degrees from angle OZ. Now we are supposed to find B, D, and C, right? Okay. So line OZ makes 40 degrees with the mirror surface. The normal OY, which was in the middle, is perpendicular to the mirror. For example, 90 degrees from the surface. This means angle D equals to 50 because they have to sum up to 90 degrees, right? Because there was a perpendicular angle there, which equals 90 degrees. So angle of reflection equals to angle of incidence from loss of reflection. Since angle B which is the angle of incidence, equals to 50 degrees, angle D equals to 50 degrees. So B equals to 50 degrees because it sums up to make 90 degrees, right? Because of this perpendicular line from O to Y, right? Then D is also equals to 50. So angle D equals to 50 because angle of reflection equals to angle of incidence from loss of reflection. Since angle B, angle of incidence equals to 50, then angle D equals to angle D equals to 50 degrees. Then angle B equals to 50 degrees. So D and B equal 50 degrees. B and D, as we can see there. Angle of incidence equals to angle between incident ray OZ and normal OY. Given the angle between OZ and the surface, which is equals to 40 degrees, angle between OZ and normal OY equals to 90 minus 40 degrees, which equals to 50 degrees. Then leaving us with angle C, which equals 40 degrees. This is the angle between the reflected ray OX and the surface of the mirror, since angle of reflection equals to 50 degrees, and normal is 90 degrees to the surface, which again is that straight line. Yeah, angle between OX and surface equals to 90 degrees minus 50 degrees, then equals to 40 degrees, right? So to some of you, I could just be saying a lot of, a lot of numbers. So this is easier when you practice. And not only that, when you also have read it from the notes, right? Because we have provided notes which explain this in full details, right? All these formulas that you're seeing here, because this is a little bit of mathematics. So we have exercises there, right? You might get more than 10 exercise questions and answers, basically talking about the mirrors and the angles, how to calculate, how to get the angles, how to memorize which one is the incident ray. So make sure to go and practice, read the notes, and then when you come across these questions, it's going to be very easy to do this. Right. So 3.2, white light is being passed through the prism as shown below. And okay, so on the left side of this diagram, we have white light with an arrow going to this triangle indicated prism. And on the right side, we have a couple of lines, but then there's also an arrowed line, a vertical, and it's labeled A at the top and B at the bottom. The middle, it's labeled visible spectrum. Okay, 3.2.1. What phenomenon is being observed above? The phenomenon being observed is dispersion of lights. 3.2.2. Write down the order of the colors from A to B. So our A to B is right there. So from the top to the bottom, we are being asked to write down the order of the colors from A to B. So there's the order of the colors from A to B is violet, indigo, blue, green, yellow, orange, red, from top A to bottom B. This is the visible spectrum formed when white light passes through a prism, and the colors spread out due to different wavelengths, bending at different angles. So unfortunately, we can only see black and white, but then on the exercises, we do have these exercises. I mean, on the 200 plus questions and answers, we have pictures, right, that also show you how those colors look like, right? Because here is only black and white. So make sure to go and look at those colors to make sense of them and actually see what those colors are. Yeah. So what do these colors represent? These colors represent the component of white light in the visible spectrum, each with different wavelength and frequency. When white light passes through a prism, it is split into its individual colors due to dispersion, a result of each color bending differently. Okay, 323. Okay, 3.2.4. Which color has the lowest frequency? The color with the lowest frequency is red, right? Okay, so that's it for question 3. And make sure to go and practice the 200 plus questions and answers, because this is there, all of it, right? And also on the notes. So make use of it, right? So that when you come through such questions, it's just going to be easy for you, right? You can literally get 100% for this. So questions for NS Term 3 notes from NS Term 3 notes. Okay, 1. Referring to 3.1, explain without defining what OZ and OX is. Okay, so they are already defined, OZ and OX. On 3.1, OZ and OX. Can you guys actually define these if you were to be asked that question in the exam? So if you want to see the answer for that question, it's there on the notes, right? So go and check it out, and so that you'll be able to see and be able to answer if it were to be asked in the exam, right? So the second question says, why does light bend when it enters a prism? And also that answer is also there on the notes for term 3. Okay. So we have our little friend here who is asking, did you know? So what is it? The normal is not an angle, it's a line. Okay, so this is referring to the mirror. However, the angle between the incident ray and the normal line is called the angle of incidence, and the angle between the reflected ray and the normal is called the angle of reflection. So to clarify, normal equals an imaginary line drawn perpendicular 90 degrees to the mirror surface at the point where the light ray hits. Okay, so that's our normal. So our normal is OY, right? So when light hits there, that means that's where we draw our normal line, right? So angle of incidence equals the angle between the incident. So all that we have also covered so far. But basically, the law of reflection is angle of incidence equals to angle of reflection, both measured from the normal, not the mirror. Okay, so let's go into question 4. So 4.1, two charged balloons are hanging from a ceiling. They are close to each other. Okay, so we can see balloon A on the left and balloon B on the right. Okay, 4.1.1, state the charge on A and give a reason for your answer. Reason, okay, A is positive. Can you confirm that? Okay. Balloon A has more positive charges, which are 14 plus, than negative, so it has 14 plus signs, right? Then negative charges of 5 minus signs, indicating an overall positive charge. Okay, so I mean, in this case, you actually have to count the plus signs on balloon A and B to make sense of it, right? Charge on B is negative. Balloon B has more negative charges, 11 minus, than positive charges, 6 plus, indicating an overall negative charge. Okay, indeed, there are a couple of minus signs in there. 4.1.3. Let's actually read that question. 4.1.3. What would you observe between the two balloons? The two balloons would attract each other. So if you can see properly, I mean, I guess through this video, I'm sure you can also see that balloon A is sort of um leaning towards balloon B. Unless it's that question paper sort of, not straight. But as far as the top line is straight, then we can sort of see that balloon A is sort of leaning towards balloon B, right? So the observation is two balloons would attract each other. Okay. So 4.1.4, opposite charges attract. Okay. Since balloon A is positively charged and balloon B is negatively charged, there is an electrostatic attraction between them, causing them to move slightly closer. 4.1.5, name the instrument used to detect the presence of charges. Instrument which is called the electroscope, right? So that's it for question 4, and I think it's the last question. And before we actually finish, so there's also other questions from the NS 200 plus questions and answers. So the first one says, determine the net charge on balloon A. Can you actually do that, you guys? I mean, if you know the answer, feel free to write it on the comments, right? And also determine the net charge on balloon B. And also that you can also write on the comments, but then if you want to see the answer, it's on the, yeah, you can only see the answer as you practice the 200 plus questions and answers for term 3, natural sciences, right? So make sure to go and practice this after you finish watching this video. So the third question says, if the string of balloon A is suddenly cut and the balloon falls, describe how balloon B might behave as a result. And also that you will see the answer as you practice the questions and answers. So that's it for this natural term 3 revision. And also these other question papers as well on academicplug.co.za. That's where you'll be able to download all the question papers that you guys will need for the whole year, right? For all your subjects, such as natural sciences, which we are doing now, EMS, technology, maths, and other subjects as well. So we also do revisions such as this one in video on YouTube for all these other subjects, right? So make sure to subscribe so that even because we have released revisions for term 3, but then we are going to release for term 4, right? For all grade 8 subjects. So make sure to subscribe so that you can get notified when we post these videos. And we do that before you guys, before the term even starts, right? So that you guys can prepare yourselves way before the exam even starts, right? But then, yeah, you can simply go to our channel, and then you can see the rest of the revisions. And don't forget to go and practice the 200 plus questions and answers. And also don't forget to download the notes. All the links to those materials are in the description of this video. And yeah, I wish you guys all the best in your exam. And I hope you have learned something from this video. And yeah, See you in the next video where we'll be doing revisions for this subject and for other subjects, right? So, peace.